AI agent security and trust infrastructure. The question of how to verify and trust autonomous AI agents is rapidly moving from academic curiosity to practical necessity. A provocative discussion on the local Llama subreddit frames the challenge starkly. Services have certificates, supply chains have SBOMs, but AI agents, increasingly capable of calling tools, triggering actions, and interacting with privileged endpoints, remain largely anonymous application code. When an agent causes damage, there's often no forensic trail to determine what agent was responsible, what it was configured to do, or what tools it had access to at that moment. The debate reveals a fundamental tension in the community. One camp argues for minimal requirements, an API key and perhaps a user agent string, with the ability to cut off misbehaving agents. But critics point out that API keys identify accounts, not actors. Keys get shared, leaked, and proxied. The just kill it if it misbehaves approach is purely reactive, offering little help when you need to prevent high-risk actions or perform clean forensics after an incident. The counter-argument gains force when considering privileged endpoints, payments, production deployments, email sending, trading. These already require more than vibes and a string. The emerging consensus suggests agent identity systems are inevitable, but might be a while yet, gated by two factors: a sufficiently simple specification, headers plus assigned blob, and killer use cases where providers actually demand verification. While the theoretical framework develops, practitioners are stress testing real defenses. A developer launched a public jailbreak challenge for Safi, an AI governance engine featuring a novel dual LLM architecture with three distinct faculties: an intellect, generating LLM, a will, gatekeeping LLM, and a conscience, evaluation layer using Qwen 32B. After 300-plus attack attempts, including multi-turn narrative attacks, fake system injections, language switching, and sophisticated Trojan horse problems wrapping harmful requests inside valid equations, 0 successful jailbreaks were recorded. The architecture's defense-in-depth approach, where even if one component can be fooled, the governance anchor provides backup, appears remarkably robust against current attack vectors. On the practical tooling front, a new open-source middleware called AI Guardrails offers a more accessible defense layer sitting between users and local LLM stacks to provide PII redaction and injection defense with under 50 milliseconds latency. It uses sentence transformers locally for semantic jailbreak detection and Microsoft Presidio for PII scrubbing. No external API calls required. Community feedback notes Presidio's limitations in clinical contexts where 99.999% accuracy is the floor, with one commenter noting a single PHI leak could trigger a 100-call-plus lawsuit. The developer acknowledges this, positioning the tool as a first line of defense. For general SaaS applications, while planning to upgrade to Gliner, generalist model for named entity recognition for improved accuracy. Section Local AI Development Tools and Infrastructure. The Model Context Protocol ecosystem continues to expand with tools designed to bring sophisticated AI capabilities to self-hosted environments. A new self-hosted MCP server now enables AI semantic search across personal databases, files, and codebases, supporting both Ollama and cloud providers for those who want optionality. This follows the broader pattern of the local AI community building infrastructure that matches cloud capabilities while keeping data under user control. A complementary project, Semantique, takes a different approach to the same problem space, providing semantic code understanding to Claude Code, Cursor, and other AI coding tools through 4 combined search strategies: semantic search using mini-LM embeddings, lexical search via ripgrep, symbol search through FTS5, and dependency graph analysis. The tool supports 19 languages with full tree-sitter parsing and runs entirely locally with SQLite, requiring no external API keys. Auto-indexing watches files and re-indexes automatically, removing the friction of manual refresh cycles. Perhaps most compelling is an experiment demonstrating that graph-based RAG can catch risks that standard vector search misses entirely. Using Ollama with Mistral Small 24B and LightRag on an RTX 6000, a researcher simulated a compliance scenario where a new contract signatory, Marcus Weber, had previously bankrupted a different company, information buried in a separate, unrelated document with no shared keywords. Standard vector search gave the green light, finding no bad news about the new company. The graph RAG system, having autonomously built a knowledge graph during ingestion, extracted the person as an entity, linked him to both companies, and correctly warned about the association with defaulted entities. This demonstrates that smaller, efficient models can achieve complex multi-hop reasoning when paired with appropriate retrieval architectures, keeping sensitive data on private infrastructure while matching capabilities previously requiring massive proprietary models. Qwen model family releases. Alibaba's Qwen team has released a significant expansion to their model family with Qwen 3 VL embedding and Qwen 3 VL re-ranker, purpose-built for multimodal information retrieval. These models, built on the Qwen 3 VL foundation, accept text, images, screenshots, videos, and arbitrary combinations of these modalities. The embedding models, available in 2B and 8B variants, generate semantically rich vectors capturing both visual and textual information in a shared space, while the re-ranker takes query document pairs and outputs precise relevance scores for pipeline refinement. The technical specifications reveal serious production considerations. The 8B re-ranker offers 32K context length and instruction-aware processing, while the 2B embedding model provides flexible vector dimensions from 64 to 2048 with quantization and MRL, Matryoshka representation learning, support. Both support over 30 languages, making them viable for global applications. The two-stage retrieval pipeline, embedding for efficient initial recall, re-ranker for precision refinement, reflects current best practices for production search systems. On the creative generation side, FIRST continues iterating on Qwen Image Edit Rapid AIO, now at version 8 with significant improvements for image editing workflows. The merge checkpoint combines accelerators, VAE, and CLIP for fast inference at 4 steps with 1 CFG. Version 8 uses BF16 to load FP32 LoRa's before scaling to FP8 for saving, which reportedly resolves grid artifacts and improves quality. The project has split into separate NSFW and SFW models after finding that combining both use cases in a single model produced subpar results, a practical lesson in the trade-offs of multi-domain fine-tuning. AI in enterprise and workplace dynamics. A developer's frustrated post about their company's blanket AI tool ban, covering ChatGPT, Claude, Copilot, and any automation platforms with LLMs, sparked an extensive community discussion about navigating corporate AI policies. The stated reason was data privacy, which the original poster acknowledged as partially valid, given their work with sensitive client information. But watching competitors move faster while doing everything manually, combined with awareness that team members were secretly using AI on personal devices, created a palpable sense of organizational dysfunction. The most upvoted response pointed simply to local LLMs as the solution, with community members noting that HIPAA-regulated healthcare and finance industries routinely run local workloads instead of cloud solutions. A nuanced security debate emerged around prompt injection risks. The key insight: locally hosted LLMs prevent data privacy issues because sensitive data stays local, but risks return when agents perform web searches, run skills from internet marketplaces, or access public MCPs. One commenter's security approach was definitive. You don't allow data ingress or exfil. If you need information, you download it, put it on your RAG server, or create skills from it. Meanwhile, IBM Research introduced AssetOps Bench, a benchmark specifically designed to evaluate AI agent performance in industrial asset lifecycle management, a domain where existing benchmarks focused on coding or web navigation fail to capture real operational complexity. The framework evaluates agents across 6 qualitative dimensions, including decision trace quality, evidence grounding, failure awareness, and actionability under incomplete and noisy data. Early evaluations reveal that many general-purpose agents perform well on surface-level reasoning, but struggle with sustained multi-step coordination involving work orders, failure semantics, and temporal dependencies. The benchmark's explicit treatment of failure modes as first-class evaluation signals reflects industrial reality. Understanding why an agent fails is often more valuable than a binary success metric. Section Hardware Security and Reverse Engineering. Security researchers from Neodyme documented their efforts to extract firmware from the Potensic Atom 2 drone, providing a masterclass in embedded systems reverse engineering. The drone, visually similar to the DJI Mini 4K with a gimbal-stabilized 4K camera, presented typical challenges. Firmware updates required valid serial numbers and were encrypted. No exposed debug interfaces like JTAG or UART were found, leaving physical extraction as the only viable option. The hardware teardown revealed a complex ecosystem of components. The SoC bore markings suggesting it's related to the SS928, a high-silicon mobile camera SoC, while the NAND flash was identified as a Macronix MX35UF4GE4AD with an available datasheet. The researchers note that some devices encrypt persistent storage with keys stored in TPM, which would have made extracted data unusable. Fortunately, the Atom 2's NAND contents were unencrypted. The series promises to cover firmware analysis and vulnerability identification in subsequent posts. A separate teardown of cheap RP2040 boards from AliExpress revealed a more subtle problem: silicon stepping misrepresentation. At $225 each, these boards appear nearly identical to genuine Raspberry Pi Picos, but with a Boya QSPI flash chip instead of the original. More concerning, while the MCU's laser markings identify it as B2 stepping, the die clearly shows RP2B0, a significant issue since B0 and B1 steppings have USB functionality bugs. Commenters clarified that B1 and B2 are mask ROM changes plus a metal eco fix, meaning the visible RDL M7 layers still show B0 markings even on genuine B2 parts. The practical advice: check the chip ID register and sysinfo from software rather than trusting package markings. Caveat emptor indeed. Open-weight model distribution. The community's appreciation for Bartowski's quantization work continued with the release of GLM 4.7 Flash in GGUF format, though the thread quickly evolved into a troubleshooting session. Users reported the model behaving as completely brain-dead through LMA Studio, with a simple Python print numbers prompt somehow triggering ruminations about prime numbers instead of producing expected output. The root cause emerged through community debugging. Flash attention needed to be disabled because llama.cpp GPU support for the new model architecture hadn't been implemented yet, causing flash attention to default to CPU processing with severe performance impacts. An important clarification surfaced: the flash in the model name refers to being small and fast, not to flash attention technology. The Unsloth team provided specific parameter recommendations that helped: temperature 0.2, top K50, top P 0.95, min P 0.01 with repeat penalty disabled. Users following these settings on RAW-CM with AMD GPUs reported the model becoming somewhat coherent and handling trick questions, though still consuming more tokens than alternatives for equivalent tasks. The episode illustrates both the value of community-driven distribution, Bartowski's quantizations are a public good, and the challenges of new architectures integrating with existing inference infrastructure. AI Research Methodologies. A new paper from researchers at Renmin University of China and Baidu introduces MatchTR, a framework addressing a critical limitation in tool-integrated reasoning for large language models. The core problem: existing reinforcement learning methods like group relative policy optimization typically assign uniform advantages to all steps within a trajectory, failing to distinguish effective tool calls from redundant or erroneous ones. This coarse-grained credit assignment becomes particularly problematic in long-horizon multi-turn scenarios. MatchTR's innovation lies in formulating turn-level credit assignment as a bipartite matching problem between predicted and ground truth tool interactions. The framework constructs a weighted bipartite graph based on similarity scores across tool names, parameter names, and parameter contents. For each interaction trajectory, a sequence of reasoning steps, tool invocations, and observations, the system extracts predicted and ground truth tool calls, then builds a matching matrix where each entry represents the matching score between a predicted call and its potential ground truth counterpart. This approach offers dual-level advantage estimation, providing fine-grained supervision that previous attempts through external reward models, susceptible to bias and hallucination, or Monte Carlo estimation, computationally prohibitive with high variance, couldn't achieve. The practical implication: Models trained with MatchTIR should develop more efficient tool use behaviors, particularly in complex multi-step scenarios requiring precise coordination between reasoning and external tool execution. Development tool evaluation. A thoughtful reflection from a developer who helped build and maintain NBDev, a literate programming environment where code, documentation, and tests live in Jupyter notebooks, explains why they no longer use their own tool. The core issue: NBDev's idiosyncratic workflow confuses AI coding tools trained on conventional source code. The AI struggles to differentiate between editing the notebook and editing the final transpiled source code, creating friction rather than flow. The post challenges several assumptions that once justified specialized development environments. Literate programming's promise of better documentation through co-location hasn't panned out in practice. Many NBDev projects still lacked sufficient documentation, reinforcing that good documentation comes from effort, not tooling. More fundamentally, AI can now read undocumented codebases and provide overviews on the fly, and can help maintain documentation separate from code by handling the tedious synchronization work. Keeping code and docs together isn't the selling point it once was. The deeper insight concerns collaboration dynamics. AI collaboration is now table stakes, and the same impediments that hinder human collaboration tend to hinder AI collaboration. Cursor won because it felt familiar and let developers change habits gradually rather than demanding new workflows immediately. As developers increasingly span greater scope, back-end people doing front-end, PMs creating prototypes, everyone becoming more polyglot, idiosyncratic frameworks isolate you from your team to a greater extent than ever before. The conclusion is characteristically direct. Discipline comes from the developer, not the environment, and tools matter less than the author once believed. Other developments. The security implications of AI-generated code are receiving systematic treatment with SEC context, a comprehensive security anti-pattern reference distilled from 150-plus sources specifically designed for LLM consumption. The statistics motivating the project are sobering. 40% of AI-generated code contains vulnerabilities. 72% of Java AI code has security issues, and AI code is 2.4x more likely to have XSS vulnerabilities than human-written code. The guide ranks anti-patterns by a matrix of frequency as 2 plus severity 2 plus detectability, with the top concerns including package hallucination. 21% of AI-suggested packages don't exist, hard-coded secrets, scraped within minutes of exposure, and broken authentication. 75.8% of developers wrongly trust AI auth code. The recommended deployment is as a standalone security review agent that checks generated code against all 25-plus anti-patterns before it reaches production. On the autonomous agent infrastructure front, several projects merit attention. Cloudflow Browser integrates browser automation with Cloudflow coordination, creating self-learning browser agents that record actions as trajectories and adapt based on success and failure patterns. Dexter provides autonomous financial research capabilities with task planning, self-reflection, and real-time market data access. Agenticorp offers an agentic coding orchestrator supporting both on-prem and off-prem development with temporal-based workflow orchestration and role-based agent personas. And Gibram provides an in-memory knowledge graph server for RAG workflows, storing entities, relationships, and document chunks alongside their embeddings with configurable time-to-live for ephemeral analysis. The proliferation of such tools suggests the agent orchestration layer is rapidly maturing beyond proof of concept into production-ready infrastructure.